Hello, welcome everyone. In this question it says mass 146 and the velocity 17, and it says what's the momentum. Formula of the momentum, P equal m times v, and m 146 times 17, which is velocity 2482, and unit of momentum kilogram times meter per second. Thanks for listening. Hello, welcome everyone. In this question it says Azad mass 21 kilogram and he's riding bicycle 5.9 kilogram and their velocity 4.5 meter per second to the northwest, and it says at A what is the total momentum. Formula of momentum equals again m times v. Now it's asking total momentum, so we have to add their masses each other. 21 plus 5.9 times 4.5, and it's equal 121.05 kilogram times meter per second. This is the A. And solution of the B, it says what is the momentum of Azad. P Azad equal m times v. Mass of Azad, which is 21 kilogram, times velocity of the Azad 4.5. So it will be 94.5 kilogram times meter per second. At the C, it says what's the momentum of bike. Momentum of the bike, that's equal m times v again. Mass of the bike 5.9 kilogram times velocity of the bike 4.5. So it will be 26.5 kilogram times meter per second. Thanks for listening. Hello, welcome everyone. In this question it says 0.5 kilogram football thrown with the velocity 15 meter per second to the right. This is important. Stationary receiver catch the ball and bring it to rest 0.020 second, and it says bring it to rest, so final velocity gonna be 0. What is the force exerted on a receiver? So we have to use momentum impulse theorem. F times delta t equal delta p. So it's asking what is the force. So force equal delta p over delta t. Delta p means m times v final minus m times v initial over delta t. So force equal final velocity of the object is 0. So it will be 0 minus m. Mass of the object is 0.5 times velocity of the object 15 to the right, so it is positive. It will be 15 over time is given 0.020. So this result will be 3.8 times 10 to 2 Newton, but result will be negative because this formula F gives us always reaction force, but here it's asking what is the force exerted on a receiver. So force on a receiver, it will be positive 3.8 times 10 to 2 Newton because it's always opposite to each other. Thanks for listening. Hello, welcome everyone. In this question it says 82 kilogram man dropped from rest on a diving board 3 meters above the surface of water, and it comes to rest 0.55 seconds after reaching the water. What force does the water exert on him? So here it's asking reaction force, and if we have a diving board like this, for example, and this is the level of the water, and this is the height of the diving board, which is 3 meters, and this is the guy here. and he jumps from here to down. So here in this question we have two cases, two parts, whatever else. The one part is in the air, the one part in water. Because in the question it says the guy dropped from rest. So here initial velocity is 0, and we have to calculate final velocity of the guy in the air, and that final velocity of the guy in the air, it will be initial velocity of the guy in the water, and final velocity of the guy in the water will be 0 again. And we can calculate this final velocity by using free fall formulas. So V final square equal V initial square plus 2gy, and initial velocity in the air, it is 0. So V final will be equal, if we take the root of the both sides, 2gy. So V final, if we substitute the numbers, 2 times 9.8 times 3 under root, so it will be positive or negative 7.7 meter per second, because it is square root. How we decide the velocity? It is in downward. Downward means negative y direction, so result must be negative 7.7 meter per second. And then it's asking what is the force exerted on him. So here its velocity will be 7.7 meter per second. For the water final, for the air final, and for the water initial, it will be again same, negative 7.7 meter per second. So F times delta T equal delta P. So as a result, it's asking F, so F equal delta P over delta T. So F will be delta P means M times V final minus M times V initial over delta T. And final velocity inside the water, it is 0. 0 minus mass of the guy, 82, times initial velocity of it, negative 7.7, over time is given 0.55 seconds. So it will be, force will be 1.1 times 10 to 3 Newton, and the direction will be up. Thanks for listening.
Hello, welcome everyone. In this question, it says we have 0.4 kg soccer ball approach the player horizontally with a velocity of 18 meters per second to the north. The player strikes the ball and causes it to move to opposite direction. Opposite means opposite of the north to the south with a velocity of 22 meters per second. What impulse was delivered to ball by the player? So it's asking impulse. Impulses, it means delta P. Delta P means change in momentum. And it's equal also F times delta T. But there is no information about force, there is no information about the time. So we will use directly delta P. And the delta P is M times V final minus M times V initial. And let's write the given first. V initial, it says initial velocity 18 meters per second to the north, so it is positive. Then V final, it says its direction opposite, so opposite means it will be negative, negative 22. So delta P means M times V final minus M times V initial. Mass of the ball 0.4 times final velocity is negative 22 minus mass again 0.4 times initial velocity is 18. So delta P gonna be 16, negative 16 kilogram times meter per second. If it is negative 16, that means direction is south. So delta P is 16 kilogram times meter per second to the south. Thanks for listening.
Hello, welcome everyone. In this question, it says we have 0.4 kilogram soccer ball approach the player horizontally with a velocity of 18 meters per second to the north. The player strikes the ball and causes it to move to opposite direction. Opposite means opposite of the north is the south with the velocity of 22 meters per second. What impulse was delivered to ball by the player? So it's asking impulse. Impulses, it means delta P. Delta P means change in momentum. And it's equal also F times delta T. But there is no any information about force. There is no information about the time. So we will use directly delta P. And the delta P is m times v final minus m times v initial. And let's write the given first. V initial, it says initial velocity 18 meter per second to the north, so it is positive. Then V final, it says its direction opposite, so opposite means it will be negative 22. So delta P means m times V final minus m times V initial. Mass of the ball 0.4 times final velocity is negative 22 minus mass again 0.4 times initial velocity is 18. So delta P gonna be 16 negative 16 kilogram times meter per second. If it is negative 16, that means direction is south. So delta P is 16 kilogram times meter per second to the south. Thanks for listening. Hello, welcome everyone. In this question it says half kilogram object is at rest. Rest means 0. That means initial velocity 0. 3 Newton force to the right acts on an object during the time interval 1.5 seconds. What's the velocity object at the end of this time interval? So at the it's asking if we apply 3 Newton force in 1.5 seconds, what is the velocity of it after 1.5 seconds? So we are going to use momentum impulse theorem. F times delta T equal delta P. So F times delta T equal m times V final minus m times V initial. And here it says object at the rest initially, so initial velocity is 0. So F is 3 times time given 1.5, that's equal mass is 0.5 times V final. So if you divide by both sides 0.5, V final will be 9 meter per second. So it says velocity final becomes 9 meters per second. And at the B, it says what? Let's see. At the end of this time interval, constant force 4 Newton to the left. That's important, left. Applied for 3 seconds. It's applied 3 seconds. So time is 3. What is the velocity at the end of the 3 seconds? So now it's asking final velocity again, but it gets some velocity. Then it's applied force in opposite direction. So we will calculate the velocity. Again, F times delta T equal m times V final minus m times V initial. Now force is given 4 Newton, but it is at the left, so it will be negative 4 times time is given 3 seconds. That's equal m 0.5 times V final is unknown minus 0.5 times V initial is here, as we calculate at the A, will be 9. So if we send this one to the other side and divide it by both sides, the 0.5, V final is gonna be negative 15 meter per second. It means V final is 15 meter per second to the left, because the result is negative. Thanks for listening. Hello, welcome everyone. In this question it says 2,500 kilogram car traveling to the north, so positive direction, is slowed down uniformly from an initial velocity 20 meter per second by the force of 6,250 braking force acting opposite direction car's motion. Use the impulse momentum theorem, answer the following questions. At the A it says, what is the car velocity after 2.5 seconds? So first of all, mass of the car, 2500 kilogram, and initial velocity, 20 meter per second. What is the direction of it? North, so it is positive. And the force here, it is given 6250, but that force will be negative because it's acting opposite direction. So at the A, it says, what is the car's velocity after 2.5 seconds? So due to momentum impulse theorem, F times delta t equal m times v final minus m times v initial, and it's asking final velocity. So if we send this one to here, and if we divide by both sides to m, v final will be f times delta t plus m times v initial over m. So v final gonna be f is negative 6250 times delta t is given in the A, 2.5 parenthesis plus mass of it 2500 times initial velocity is 20 over m is again 2500. So the result will be 14 meter per second. So to the north it will be. And at the B it says, how far does the car move during the 2.5 seconds? So we have to use kinematics equations. X equal half v initial plus v final times t. So if we substitute the value half, initial is 20 plus final is, as we calculate, 14 times 2.5. So result will be 42 meter to the north again. At the C, it says, how long does it take the car to come complete stop? Complete stop means final velocity of the car is gonna be 0. So from the momentum impulse theorem, F times delta t equal delta p, and delta t equal delta p over f, yani m times v final minus m times v initial over f. And the final velocity will be 0 because it says complete stop. So 0 minus m is 2500 times initial velocity is 20 over f is negative 6250. So result will be 8 seconds. And the time can be only positive. Thanks for listening. Hello, welcome everyone. In this question it says 63 kilogram astronaut is on a spacewalk when the tether line to the shuttle breaks. The astronaut is able to throw spare 10 kilogram oxygen tank in a direction away the shuttle at the speed of 12 meters per second, propelling the astronaut back to shuttle. Assuming the astronaut starts from rest, so initial velocity of astronaut rest with respect to the shuttle, find the astronaut final speed with respect to the shuttle after tank is thrown. So if the astronaut initially at rest, so oxygen tank also at rest because it's with astronaut. This is the conservation of momentum. So m1 times v1 initial plus m2 times v2 initial, that will be equal m1 times v1 final plus m2 times v2 final. And if the astronaut at the initial rest, oxygen tank and the astronaut must be at rest. So both velocity of the astronaut and the oxygen tanks will be 0. So due to this, the left side of the equation gonna be 0. And then if we send this side to other side, so m1 times v1 final must be equal negative m2 times v2 final. And m1, let's say it is the astronaut, so it will be 63 kilogram times v1 final, we don't know, which is the question, minus m2, which is the mass of the oxygen tank, which is 10 kilogram, times velocity of the oxygen tank is 12 meter per second. So v1 final, it means the final velocity of the astronaut will be 1.9 meter per second to the shuttle. Thanks for listening. Hello, welcome everyone. In this question it says 85 kilogram fisherman jumps from dock into 135 kilogram rowboat at the rest on the west side of the dock. If the velocity of the fisherman 4.3 meter per second to the west as he leaves the dock, what is the final velocity of the fisherman at the boat? Let's say this is the boat, like this. This is the fisherman, like this. If the fisherman jump into it, so they will move finally, boat and the fisherman together, we can say. Our formula, first of all, m1 times v1 initial plus m2 times v2 initial, that's equal m1 times v1 final plus m2 times v2 final. But here, final velocity of the boat and the final velocity of the fisherman must be same, because the fisherman jumps from dock to boat, so they are moving together. Their final velocity must be same. As a result, v1 final must be equal v2 final, so we can say they are equal v final. So here, side of the equation, there will be common factor. So m1 times v1 initial plus m2 times v2 initial will be equal v final parenthesis m1 plus m2. So due to this formula, we will do our calculation, and question says what's the final velocity. If we divided both sides m1 plus m2, we will have the equation for the v final, m1 plus m2. So v final will be m1 times v1 initial plus m2 times v2 initial over m1 plus m2, we can say. And the m1 is the mass of the guy, which is 85, and velocity of the fisherman given 4.3 to the west, so it will be negative 4.3 in the parentheses, plus initial velocity of the boat is 0, so it will be 135 times 0, so it will be 0 anyway, over 85 m1 plus 135, let me say m2, so results will be negative 1.66 meters per second. That means v final is 1.66 meter per second to the west. Thanks for listening. Hello, welcome everyone. In this question it says each cricket ball in a set has mass 0.5 kilograms. So each one 0.5. The green ball traveling 12 meters per second strikes blue ball, which at rest. So green one, it is moving 12 meters per second and it strikes the blue one, which is at rest. That means velocity of it 0. Assume that the balls slide on frictionless surface and collision are head-on. Find the final speed blue ball in each following situation. At the A, it says what? Let's see. The green ball stop moving after it strikes the blue ball. It means at the A, final velocity of the green ball will be 0. Our formula is the conservation of momentum, m1 times v1 initial plus m2 times v2 initial, that will be equal m1 times v1 final plus m2 times v2 final, we can say. And let's use this side for the A. Yes, m1 first object is the green ball, let's say second object is the blue ball. Initial velocity of the blue ball is 0, and the final velocity of the green ball, due to given it says, let's say it's stop, so this will be 0. So m1 0.5 times v1 initial is the 12 plus 0, I'm not writing that. m2 is 0.5 times v2 final, that means final velocity of the blue ball. So v2 final will be 12 meter per second. It will be same direction as the green ball. At the B, it says the green ball continues moving after collision 2.4 meter per second in the same direction. So again, we're gonna write same formula, m1 times v1 initial plus m2 times v2 initial, that's equal m1 times v1 final plus m2 times v2 final. Now initial velocity of the blue ball is 0, so this one will be 0, but at the B, final velocity of the green ball different than the 0. So m1 0.5 times initial velocity of the green, it is 12 again, same, plus 0, that's equal 0.5 times the velocity of the green ball given 2.4 plus 0.5 times v2 final. And if we do calculation, and if we send this one to other side and divide it by both sides 0.5, v2 final will be 9.6 meter per second. As the same direction. Thanks for listening. Hello, welcome everyone. In this question it says 2 kg skateboard initially at rest tosses 8 kg jug of water in the forward direction. If the jug has speed 3 meter per second relative to ground and the boy and skateboard move in opposite direction at 0.6 meter per second, find the boy's mass. In this question we have a skateboard, we can say, and there is a guy on it, and that guy throw a jug, we can say, in the forward direction with the velocity of 3 meter per second. And the mass of the skateboard is 2 kg, and the mass of the boy is unknown, and mass of the jug is 8 kg, and speed of the jug is 3 meter per second. So we will calculate this by the conservation of momentum formula, m1 times v1 initial plus m2 times v2 initial, that will be equal m1 times v1 final plus m2 times v2 final. Here in this question, actually we have 3 different objects, but in the question it says boy and skateboard move together. So we can accept they have combined mass. So m1 will be 2 plus mass of the boy times v1 initial, that is v1 initial, it says they are at rest, so it will be 0, plus m2 is the mass of the jug, it will be 8 times. Initially the guy is holding the Jack. So if the guy at rest initially, so Jack will be at rest initially also. So it will be 0. That will be equal m1 2 plus mass of the boy times velocity of the boy and the skateboard 0.6 but opposite direction, so it will be negative 0.6 plus m2 is the 8 times velocity of the jack is given 3 meter per second, so 3, it is positive 3 we can say. So if we send this one to other side, it will be 0.6 times 2 plus mass of the boy equal 24. If you divide both sides, 0.6 2 plus mass of the boy will be 40. So if we send it to other side, mass of the boy will be 38 kilogram. Thanks for listening. Hello, welcome everyone. In this question it says 1500 kilogram car traveling 15 meter per second to the south means negative, collides with the 4500 kilogram car truck at initially at rest. So 4500 at rest, stoplight. Car and truck stick together and move together after collision. That means this makes this type of collision perfectly inelastic. What is final velocity of the two vehicles' mass? So formula of the perfect inelastic collision, m1 times v1 initial plus m2 times v2 initial equal v final times m1 plus m2. And in this question it's asking final velocity, so if you divide both sides, m1 plus m2, m1 plus m2, so v final will be m1 times v1 initial plus m2 times v2 initial over m1 plus m2. So first one is the 1500 first mass times it is traveling 15 meter per second to the south, so direction negative, so velocity will be negative, plus m2 4500 times its initial address, so velocity of it will be 0 over m1 1500 plus m2 4500. So as a result, v final will be negative 3.75 meter per second. It means v final is 3.75 meter per second to the south. Thanks for listening. Hello, welcome everyone. In this question it says grocery shopper tosses 9 kilogram bag of rice into stationary 18 kilogram grocery chart. The bag hits the chart with the horizontal speed 5.5 meter per second toward the front of the chart. What is the final speed of the chart and back? That means chart and back, they are moving together. So we can say m1 times v1 initial plus m2 times v2 initial over m1 plus m2. The m1 is the 9 kilogram times what is the initial velocity of the m1? It's given 5.5 plus mass2 is the mass of the grocery chart, it is 18 kilogram times, and it says stationary grocery chart. Stationary means it's initially at rest times 0, it means, so over 9 plus 18, so v final will be 49.5 over 27, so it will be 1.83 meter per second. So it will be in same direction as the rice. Thanks for listening. Hello, welcome everyone. In this question it says 1.5 times 10 to 4 kilogram railroad car moving at the 7 meter per second to the north, so it is the positive, collides with and stick another railroad car of the same mass, so mass will be same, that's moving in the same direction, 1.5 meter per second, so it's also positive. What's the velocity of the joint cars after the collision? Joint means final velocity same, so m1 times v1 initial plus m2 times v2 initial equal v final times m1 plus m2. So v final will be m1 times v1 initial plus m2 times v2 initial over m1 plus m2. So first mass is the 1.5 times 10 to 4 and it is velocity 7 to the north, so it is positive times 7 plus second mass, again the same, it says 1.5 times 10 to 4 times its velocity 1.5 over m1 plus m2, they have same mass, we can make it like 2 times 1.5 times 10 to 4 directly. So V final will be 4.25 meter per second. So it's positive, so to the north. Thanks for listening. Hello, welcome everyone. In this question it says dry cleaning throw 22 kilogram bag of laundry on the stationary means zero velocity, 9 kilogram chart. The chart and laundry bag moving 3 meter per second to the right, so it is the positive. Find the velocity of the laundry bag before collision. So formula is m1 times v1 initial plus m2 times v2 initial, that's equal v final times m1 plus m2. So m1 is the 22 kilogram mass of the laundry bag, and it is what is the initial velocity? It says find the velocity of the laundry bag before collision, so it's asking v1 initial plus m2 is the 9 kilogram, but it says it is stationary, so its velocity 0. Final velocity of them 3 meter per second to the right, so it is 3 times m1 is the 22 plus m2 is the 9. So 22 times v1 initial equal 3 times 22 plus 9. So if we divide by both sides 22 and 22, v1 initial will be equal 4.2 meter per second to the right, because the result is positive. Thanks for listening. Hello, welcome everyone. In this question it says 47.4 kilogram students runs down the sidewalk and jumps with the horizontal speed 4.2 on the stationary skateboard. Down means here center. Stationary skateboard, that's important. The student and skateboard move down the sidewalk with the velocity of 3.95 meter per second. So this is the final velocity of the boat. Find the following: the mass of the skateboard at the A it's asking. Formula is m1 times v1 initial plus m2 times v2 initial, that's equal v final times m1 plus m2. Let's keep this part for the B. So initial velocity of the skateboard is 0, so this will be 0. And mass of the student 47.4 times initial velocity of the student is 4.2. That will be equal v final times m1 plus m2. And v final is given 3.95 M1 again 47.4 plus M2, that is the mass of the skateboard, we can say. If we divide both sides 3.95, if we send it the other side, M will be 3 kilogram. And at the B it says how fast student would have to jump to have final speed 5 meter. So now it says how we can make the final speed 5. So initial speed must be different than 4.2. So again, M1 times V1 initial plus M2 times V2 initial, that's equal V final, M1 plus M2. And again, skateboard initial at rest, so this will be 0. And M1 is 47.4 times V1 initial is unknown, it's asking V1 initial, that's equal, V final will be here 5 because it says how it can be 5 times M1 is 47.4 plus M2 is 3. Now it is not unknown. If we divide by both sides, 47.4 V1 initial will be 5.3 meter per second. Thanks for listening. Hello, welcome everyone. In this question it says 0.25 kilogram arrow with the velocity of 12 meter per second to the west, that means negative, strikes and pierces the center of 6.8 kilogram target. What is the final velocity of combined mass? So we have an arrow and we have a target, we can say like that. It will hit and combine with the target, the arrow. And at the it's asking what's the final velocity of the combined mass. At the we have to use the formula of V final equal M1 times V1 initial plus M2 times V2 initial over M1 plus M2. And first mass is the 0.25 times velocity is the 12, but it will be negative 12 because it's the west, times initial velocity of the target is 0, so this will be 0 over M1 0.25 times 6 point plus 6.8, and this will be equal negative 0.43 meter per second. That means 0.43 meter per second to the west. And at the B it says what's the decrease in kinetic energy during the collision. So we have to calculate kinetic energy initial. Kinetic energy initial means half M1 times V1 initial square half M2 times V2 initial squared. And second object initial velocity is 0, so this will be 0 and this will be half times M1 is 0.25 times V1 initial is the negative 12 squared, so the result will be 18 joule. And the kinetic energy final will be half M1 plus M2. Why M1 plus M2? Because they combine, so we can accept their one mass times V final squared. So half M1 is 0.25 plus M2 is 6.8 times V final is negative 0.43 squared. So result will be 0.65 joule. So it says decreasing, so delta kinetic energy equal kinetic energy final minus kinetic energy initial. So 0.65 minus 18, it will be negative 17.35 Joule. Thanks for listening. Hello, welcome everyone. During the practice, students kicks 0.4 kilogram soccer ball with the velocity of 8.5 meter per second to the south. South means negative, into 0.15 kilogram bucket lying on its side. Lying means velocity of it 0. The bucket travels with the ball after the collision. They are traveling together, so that means combined mass. What's the final velocity of the combined mass? So V final equal m1 times v1 initial plus m2 times v2 initial over m1 plus m2. And the bucket is lying, so velocity of the bucket initial is 0, so this will be 0. And m1 is the 0.4 times velocity of it 8.5, but to the south, so it will be negative 8.5. So plus 0, no need to write it there, over m1 is 0.4 plus m2 is 0.15. So the result will be negative 6.2 meter per second. That means V final is 6.2 meter per second to the south. And at the B, it's asking what is decrease in kinetic energy during the collision. So we're going to calculate kinetic energy initial kinetic energy half m1 times v1 initial square plus half m2 times v2 initial square. And second object is at the rest, so this will be 0. It will be half times m1 is 0.4 times v1 initial is 8.5 at negative 8.5 squared. So the result of this will be 14.65 joule. And we have to calculate kinetic energy final. At the final, half m1 plus m2, because they are combined, times v final squared. So half m1 is the 0.4 plus m2 is the 0.15 times v final is the, as we calculate, negative 6.2 squared. So this result will be 10.57 joule. So kinetic energy final minus kinetic energy initial, it will be final 10.57 minus initial 14.65, that will be equal negative 3.94 joule. Thanks for listening. Hello, welcome everyone. In this question it says 56 kilogram ice skater traveling 4 meters per second to the north. That means positive, meet and join hands with the 65 kilogram skater traveling 12 meters per second in the opposite direction. Opposite direction means opposite velocity, that means negative velocity. Without rotating, the two skaters continue skating together with the joint hands. That means combined mass again. What is the final velocity of the two skaters? So at the A we will use the formula V final m1 times v1 initial plus m2 times v2 initial over m1 plus m2. So mass 1 is the 56 kilogram times its velocity 4 to the north, so it is positive, times 4 plus m2 is the 65 kilogram times its velocity opposite direction, so it will be negative 12 over m2 and M1 56 plus 65. So the result will be negative 4.6 meter per second. So V final is 4.6 meter per second to the, here it's given north, so it will be south. And at the B it says what is the decrease in kinetic energy during the collision. So we have to calculate kinetic energy initial and kinetic energy final. So initial kinetic energy half m1 times v1 initial square plus half m2 times v2 initial squared, and half m1 is 56 times v1 is 4 squared plus again half m2 is 65 times v2 is negative 12 squared, and so result will be 5200 joule. And kinetic energy final will be, because they are combined, half m1 plus m2 times v final squared, so half 56 plus 65 times v final is negative 4.6 squared, so the result will be 1300 joule. So kinetic energy final minus kinetic energy initial to calculate the decrease. So 1300 minus 5200, so it will be negative 3900 joule. Thanks for listening.